What's going on in this situation? We got 9 men, they got to move this much, and they can do it in 2 hours. But as they were moving stuff around, they lost 5 guys, yeah.
They already unloaded it on 150 kilograms.
All right. They already moved 150 kilograms, so we're set there. And they lost how many people?
5.
Lost 5 men. Now what is the question asking?
How many more hours they need for the remaining 4 men to unload the rest?
All right, so now instead of 9 men, we got 4 men. They say move the rest. What is the rest? So you do 450 minus 150, 300. So they got to move 300 kilograms, and they want to know how long that'll take. So your goal is to turn 9 men into 4 men, 450 to 300, and then figure out that time. So the question is this: how do I change from one thing to another? Yes?
Well, I divided 9 in the 450 by 9. You want to find how much?
All right, so if we're talking about, we want to figure out just 1 man, is that what you're saying? So you're saying, well, let's just divide that by 9. 9 divided by 9 will take 1 man. And let's say it takes the same amount of time. If he wants to get done in 2 hours, can he move all those 450 kilograms? No. So what do I do with that 450? Divide by 9. So that's 50 kilograms. So it takes 1 guy 2 hours to move 50 kilograms. That's his rate. So we're getting there. What do we do next? Go ahead.
So you want to find 1 hour? And then I divided by 2.
Why do we want to find 1 hour?
Because it'd be like,
Is it asking for 1 hour?
no, it's saying how long.
Oh. So let's not find out 1 hour because we don't know how many hours it's going to take. So we don't want to mess with the hours yet. We want to mess with these guys. Sam. Multiply by 4. So you're saying multiply this by 4. So it'll take, so we got 4 men. And we're saying keeping the time the same, basically. Because when it comes to these ratios, you can only mess with 2 things at a time. So 4 men, if it's going to take 4 men 2 hours to get work done, is it going to take 4 men 2 hours to move 50 kilograms? No. They would have to move more or less. So they're going to have to move more to have the same amount of time. So you could do that, but now we got 200, but what does that say? 300. So the question is, how do you turn a 200 into 300? So this is right, but that might not be helpful. So how much weight are they moving? 300 kilograms, yes.
Could you change the time instead of in the kilograms? Like the men in the time instead of the pounds?
All right, you can change the men and the time. So the idea is the same. You can change the men, so multiply by 4 to get 4 men. But we're going to say 4 men moving 50 kilograms. So I'm going to ask you this. 1 guy takes 2 hours to move this much. Is it going to take more or less time for 4 guys to move the same amount of stuff? It's going to take less time. So what do I do with this 2? We're going to have to divide by 4. What's 2 divided by 4? So it's going to take 4 guys a half hour to move that much. Now we're getting somewhere. So we got our 4 men, but we don't have this. So how do I deal with these guys? Yes, Alexis?
Multiply by 6.
Yeah, just multiply by 6. 50 times 6 is 300. So again, the men we're not messing with. So the question is this. If it takes 4 guys a half hour to move this much, is it going to take them more time or less time to move more stuff? It's going to take more time to move more stuff, correct? So I'm going to have to multiply by 6. What's 6 times a half?
3.
Yeah, it's 3 hours. So your final answer, 3 hours. So you'll notice when we mess with this, when we mess with men and weight, we treated them the same. Because we're like, if it takes the same amount of time and we have fewer guys, we're going to have fewer weight to move around. But when we're comparing men and hours, if we have the same amount of weight but we have more men, it's going to take less time. So you got to realize when you're messing with one, you might have to do the opposite to the other. All right, so Alexis was like, well, instead of doing it this way, she just said this. What if I divide by 2 to figure out 1 hour? So what is your is it hours with weight or hours with men?
Hours with weight.
All right, so if it takes less time and you have the same amount of, you have one guy, I guess it really doesn't matter. I guess my question was, why did you do that? But that's fine. So what's 50? So that means if you have one guy and it's going to take less time, he needs less weight, right? So you just divide by 2. So you got 25 kilograms. And then what did you do from here?
And then I multiplied the man in kilograms by 4. And then
So you multiplied by 4. So you got 4 men. And it's going to take, if it's the same amount of time, you're going to need more weight. So that's 100 kilograms. And then you did this, multiplied by 3. And multiplied by 3. So yeah, that does work. I guess the question is like, why are you doing it? And since you explained it, yeah, it works out just great. All right, so there you go. So we have 4 skilled workers. And they can do a job in 5 days. And they tell you that 5 semi-skilled workers, it's going to take longer, I'm assuming, in 6 days. And what is the question asking? They want 1 semi-skilled and 2 skilled workers. So the question is this, and I'll put the question right there. So they want 1 semi and 2 skilled. Now the problem I have here is that I have 2 different types of people, and that just gets confusing. So your goal is to do this. Try to find a common denominator for the skilled workers and semi-skilled workers. In this case, what would be the common denominator? The days. I'm going to have to try to make them the same. That says 5 days, that says 6 days. So something's got to be the same. So let's make the days the same. Let's use 30. So you got to multiply by 6 to make that 30 days. So if I multiply that by 6, I'm going to have to divide this by 6, yes? Because if it's going to take more time, you need less workers. So in this case, it's going to take 2/3 of a skilled worker. So not literally, you can't get a person, chop them up into 3 pieces, and 2 of those pieces are going to get the job done. But the relationship is going to be helpful here, because I'm not done yet. I'm just looking for the final product right now. Here, I got to multiply by 5 to get 30 days. And again, the question I ask, if it's going to take more time, I'm going to need, I have less workers, so I'm going to have to divide. So 1 semi-skilled worker is the same as 2/3 of a skilled worker. So that's our relationship. So I look here, because this is what the question is asking. What if I had these 2 guys working together? Well, instead of using semi-skilled, what should I replace it with? So we're going to say this guy is a 2/3 of a skilled worker. And what's 2 plus 2/3? 2 and 2/3. So now that is my question. So now I'm changing the question around. I'm not asking how much 1 semi-skilled worker and 2 skilled workers add up their work to. I'm just going to ask how much 2 and 2/3 of a skilled worker can get their work done. Actually, let me fix this. So we know that 2/3 of a skilled worker can get the job done in 30 days. Correct? And what am I trying to find again? 2 and, so I'm trying to turn a 2/3 into a 2 and 2/3. But that's a mixed number, and that's a fraction. So what should I do with this mixed number? Let's make it improper. 3 times 2 is 6 plus 2 is. So instead of saying 2 and 2/3, just let's make it into an 8/3. So how do you turn a 2/3 into an 8/3? So I'm going to have to multiply by 4. 2 times 4 is 8. 3 times 1 is 3. Good. So I'll ask this. If you're getting more workers, will the job get done longer or quicker? Quicker. So what do I do to this side? Divide by 4. How many times does 4 go into 30? 7. How much is left over? 2. So 7 2/4 of a day. But what's 7 2/4 of a day? 7.5 days. Any questions on what I did here? Any thoughts?